Hi, my name is Ryan Ambrose, and I'm a PhD candidate at Dalhousie University. I'm a member of Dr. Ian Hill's lab, where we are a part of Theme 2 in the NSERC-GreEN network. Our role in the network is to characterize the novel green materials being produced by teams in Theme 1, where we achieve this by studying their frontier electronic structure. To do this measurement, our group uses photoelectron spectroscopy, where we use light of a known energy to probe the occupied electronic states inside the material, where we take advantage of the photoelectric effect. To fully characterize these new materials, however, we have to do three separate experiments. One of these experimental techniques is XPS, or X-ray photoelectron spectroscopy, where we use X-rays or very high energy light to study the chemical composition of these new materials, which can tell us things like the stoichiometric ratios. As well, we can learn details about the individual chemical environments. A similar experimental method is UPS, or ultraviolet photoelectron spectroscopy, which uses ultraviolet light, which is light of much lower energy, to instead probe the frontier occupied electronic structure of these materials. The last experimental method is IPES, or inverse photoelectron spectroscopy. Instead of using light of known energy and measuring the electrons coming out, we instead use electrons of known energy and we measure the photons that come out of our material. In this way, we can instead measure the frontier unoccupied electronic states. Putting these experimental techniques together, we can fully characterize the frontier electronic structure of these materials, which is very important to its performance in a device because this gives us the material's ionization energy, electron affinity, and electronic bandgap. We've performed this characterization with several materials in the NSERC-GreEN network, and some of which have already led to publication. For example, we were able to determine the charge ejection barrier between metal thiocyanines produced in the network in various other metal electrodes, where this is important in optimizing the performance of organic transistors. I want to finish off with an open invitation to the NSERC-GreEN network. We are always looking for new collaborators, and we love working with novel materials that are being produced by the network. So come join us.